Hello, my name is Daniel Castro. I'm Vice President of ITIF, the Information Technology and Innovation Foundation, and Director of ITIF's Center for Data Innovation. I want to welcome you to today's panel on harnessing AI for carbon neutrality. As we all know, we're seeing a growing wave of applications that are taking advantage of the latest advances in artificial intelligence to deliver solutions in basically every sector of the economy. And as we're seeing this, we're also seeing a lot of interest in how AI can be used to address climate change, to reduce carbon emissions, and to create a more sustainable economy. Every week, if you read our newsletter, you'll see that there are new amazing use cases for how AI can create climate solutions. Ideas like using computer vision for environmental monitoring of marine life, or using computer vision for automating recycling plants. Or using machine learning for things like optimizing grid efficiency or figuring out where we should place electric vehicle charging stations. Just this past week, Jeff Bezos's Earth Fund announced $100 million for AI solutions that could address issues like sustainable protein, biodiversity conservation, and power grid optimization. So the use cases are growing and the opportunities are growing. And really what we want to do with the panel today is discuss the landscape of AI applications that can help us transition to a greener economy and identify the key areas that are ripe for exploration, and then discuss the actionable policy measures that can be used to foster innovation and adoption. To do this, we have a really great set of speakers to weigh in on these issues. Joining me today are Constanza Gomez-Mont, founder and principal of C-Minds, Colin McCormick, Chief Innovation Officer at Carbon Direct, Reina Atsuka, Digital Innovation Lead for Nature and Climate at the United Nations Development Program, and Josh Parker, who's Senior Director of Corporate Sustainability at NVIDIA. All of our guests today also are invited to ask questions of our panelists on our website or in the video description. If you're watching on YouTube or Facebook, you should see a link to Slido. You can go there and submit your questions or vote on questions asked by others. But let's just jump right in. And I want to start by having us discuss the current set of AI applications and opportunities. So Constanza, let me start with you. What are some of the successful examples of AI applications that you're seeing currently used to reduce carbon emissions?
Sure. So thank you for the invitation. Firstly, we cannot talk about climate change and carbon if we don't talk about biodiversity conservation. So as we for sure know, biodiversity conservation can have the potential to add up to 30% of mitigation action. So answering what is the role of AI for this field, specifically for nature-based solutions, becomes crucial. One of the amazing case studies we've been seeing in this application of AI for this field has actually been from Latin America. As you for sure know, Latin America hosts more than 40% biodiversity. So talking about the intersection of AI and biodiversity, carbon mitigation, and for this region becomes key, not only for the region itself, but on a global landscape. Specifically, what we have been seeing, and actually part of our work has been exploring how AI can become a very effective tool for monitoring, verifying, and reporting initiatives for conservation. For example, cases go from using to see and understand the patterns of images captured by camera traps, for example, in the rainforests of the southern Mexico, to identify jaguar population and understand the patterns of the jaguars and see if they're connected with the biological corridors, and as well to analyze through audio maps of the ecosystem to understand the ecosystem's health. For example, for us, we've been using deep learning to understand sound patterns.
It looks like we've lost Constanza for a minute, so let's give her a second to reconnect. But while she does, let me go ahead and move on to Colin, and I think we'll come back to her points on biodiversity. So Colin, I know you've done a lot of work in this area, including leading this great report that looked at kind of a roadmap for how we can deploy AI. So I wanted to ask you, what are some of the examples you're seeing globally? And Constanza, we'll return to you in a moment.
Well, thanks, Daniel. I'll jump in and give just a a brief highlight of some of those. We're seeing wonderful use cases in global GHG emissions monitoring, so enabling higher spatial and time resolution of exactly where greenhouse gases are coming from and attributing them more specifically to companies and facilities. That's things like Climate Trace, which I'm involved in. You're seeing Carbon Mapper, Kairos, quite a few use cases here where it's leveraging remote sensing satellite data and machine learning algorithms on the back end. Lots of great forest monitoring. We just saw this week Meta and WRI release a global canopy height data set that uses a lot of machine learning on the back end to understand very high spatial resolution global tree canopy height. Really exciting stuff in materials discovery for energy technologies and related climate tech. Perovskite materials, lithium-ion battery electrode electrolytes. We're seeing catalysts. We're seeing all kinds of fun stuff there. A really cool use case there is not just the materials discovery, but the use of natural language processing to summarize existing scientific literature. 10,000 papers that no human could read can be ingested by NLP and synthesized to speed up further research in that area. A lot of other great use cases I'll just mention very briefly. Aviation contrails rated forcing, which is a really interesting and important area for aviation impact. Optimizing wind and solar generation. We're seeing, of course, for many years, we've seen use cases in smart ag, precision farming, and the list goes on, but I'll pause there. It's really exciting to see all of these use cases emerging from research and increasingly penetrating into actual use case in the world.
Thanks, Colin. And Constanta, let me go back to you. I know you were talking about biodiversity in Latin America and opportunities there, and I just wanted you to be able to finish your thought. If we have you, but we might still be having some technical challenges here. So we'll come back to you in a moment then. So Raina, let me go to you. I'd like to ask, what are the opportunities in this space that you're most excited about?
Sure. We see, of course, the examples that Constance and Colin both mentioned already, but just maybe to add to it, the adaptation is also another important aspect of this, and especially because UNDP, we support the developing countries. We're present in more than 170 countries and territories, basically in the developing parts of the world. And for now, I think the biggest application we see is for policy decision making. For example, we've supported on coastal line erosion prediction. Of course, these are still not as precise probably, but it's still a great way of policy discussions and making some decisions on investment. Also, for example, in India, we have a few ways of using AI to identify adaptation policy impact. So there's a platform called DICRA that the India country office developed with the state of Telangana. And they try to use AI and machine learning with partnership with academia to identify which agriculture policies are affecting which plots in what way. And then they also have a way of ground proofing it with the citizen science data that we also tend to collect on the ground. So I think we're still in the process of figuring out how to apply this in a safe and inclusive way. There's a lot we can talk about that too, but I think adaptation is really a big area that we see just happening.
Thank you, Raina. And Josh, same question to you. Kind of what opportunities are you most excited about?
So maybe I'll be able to try to consolidate what folks have said and add just a little bit. Don't want to belabor the point, but the three main areas that I see real opportunity for AI application here. Number one, research and analysis to make sure that we have enough data to be able to, as Colin was suggesting, make good decisions about climate adaptation or climate mitigation. Second major area is discovery and innovation. Again, as previously mentioned, discovery of new materials, new technologies for carbon capture, et cetera. Lots of opportunities for AI to facilitate that. And then finally, AI is really, really good at optimization, which leads directly to efficiencies. Efficiencies can be in Of course, optimization of grid, which leads directly to reduction in energy and potentially reduction in emissions as well, but also efficiencies around resources, because AI, especially when combined with technologies like virtualization, allows you to do a lot in the virtual world without having to expend resources in the real world. And so you're able to do a lot of work virtually that saves both resources and emissions on the back end. So 3 very broad categories with a lot of potential in each, I think.
Thanks, Josh. And Constanza, 3rd time's the charm. I want to go back to you for the
There you go.
point. I think we're good now.
Yes, thank you. In AI conferences, having technical difficulties sounds, paradoxical. Finishing that idea, I believe that one of the most promising AI applications we've been seeing in the region has been not only what happens with better efficiencies, for example, in agriculture, but how AI is also considered a tool to rethink what climate justice and regenerative justice means for the area. So that will circle back to what Reina was saying, about the ethical approaches and about not only mitigation, adaptation, resiliency, but rather how can we have the community at the center of any AI approach, specifically for regions that where disparities and social disparities are already there.
Thanks. I want to stay on that point, and Reina, maybe bring you in on this question too. Thinking specifically about extreme weather events and natural disasters that you mentioned. How should we be using AI in this space to predict and mitigate the impact of climate change related events in this area? What should we be focused on kind of short term, and where should this focus change as AI continues to advance?
Sure. I mean, apparently or obviously, right? Like the weather forecast is getting better. That also involves a lot of AI behind the scenes. So applying that at a local scale is something that I know many people are looking at.
Yeah.
And also making sure that it's overlaid with socioeconomic data. So scientific data is one thing, but I do think there's still a disconnect between what the academic research can come up with versus how does it apply to the socioeconomic scenes, as well as, of course, how do we approach it as a policy. So I think that's one big area we are constantly looking at. But I do want to remind that in a lot of these countries, the base data is not there. And I'm actually curious to see, how Josh, I know you guys are really strong in this data backend as well, how we should approach this. But for example, in Malawi, when we talk about an early warning system, the support to the country, we started from digitizing the paper-based historical weather data and put it in the database. And that's where we had to start in order to get to the early warning system, which is where AI can start to play a role. So I think we also do want to be really cautious that data is really not equally distributed across the world. Talking about biodiversity, right? Biodiversity data, if you look at, for example, the GBIF database, there's a biodiversity database that you can see that all the most biodiversity rich countries is not where all the data is coming from. It's usually coming from the US and the European states. So how can we actually reverse this or strengthen the areas where the adaptation is more in need is something that I think we're trying to look into in both the short and long term, I suppose. So I'm really curious to hear what others are doing and thinking about this as well.
Thanks, Reina. And Josh, do you want to jump in on this question as well as Colin?
Sure. Yeah, there's a huge amount of potential for AI and its application in weather prediction and climate forecasting. A lot of work going on here, and we at NVIDIA partner with a lot of different organizations to try to develop tools and models that will really help. There is a data problem, so trying to do what we can, the best we can with existing data is one thing that we need to work on, and AI can help with that for sure. We just announced last month a new model a new tool that we've developed called Core Diff that allows you to downscale 25-kilometer data to 2-kilometer data and still provide very accurate weather forecasts. We demonstrated this with a typhoon in Taiwan and showed how effective it was. So AI is really kind of breaking some boundaries that we have from kind of historical numerical based predictions allowing us to be much more efficient, much more, which enables much more accurate forecasting. So we're just starting to scratch the surface. Of course, having more data to use as the input will lead to better data on the output. But AI is really giving us a quantum leap forward in using existing data to come up with really useful weather and climate forecasting.
Thanks, Josh. Colin, did you want to add something?
Well, that's great. I wanted to go maybe a little bit to this point about biodiversity and particularly species monitoring. I have seen some really interesting use cases, and I'm involved in some that are looking at, for instance, the spread of disease vectors, so mosquitoes or kissing bugs with Chagas disease, where they're moving into new regions and monitoring for them is very labor intensive to be done manually. But computer vision algorithms can take a photo that was from a cell phone camera and tell you right away whether this is a species of concern, geolocated, that can then give you species distribution tracking that's much, much more rapid and intensive. When that's linked to a health outcome, like with Chagas disease, I have a former student at Georgetown who's been working on this. It's able to extend some of the capabilities of health access very far out into the field. So if a cell phone photo of a bug, this bug just bit me, should I be worried? Do I need to go to the clinic, which might be very, very challenging? That can then, analysis can be applied, computer vision analysis can be applied to then give that kind of health information support all the way out to someone who may be very far from conventional medical facilities. So those are innovative, interesting ways to approach this problem. They need a lot of support. And they won't just deploy magically. I do think it's an area where policy support is needed, but I think there's opportunities there.
Yeah, and Constanza, I want to ask if you could weigh on this as well in terms of some of the projects that you had mentioned, and whether they are kind of citizen science efforts, if they're well-funded grants. I'm curious kind of the trajectory they've been taking and the trends you're seeing in that space.
Yeah.
So both, actually, and one of the most interesting aspects of our work is what we've seen is decentralizing, the production of data. So when we have tools, and for example, right now we have a tool where if you have an audio from the rainforest, for example, and you want to see what species exist there, and then the patterns of the species, so mobility and patterns and such, you can upload this audio to a platform we have in collaboration with Rainforest Connection, and then there's audio pattern recognition. And for now, in a very short amount of time, like in around 4 months, we have identified more than 120 species. That is not only the health about this territory, but also, the question about how do we democratize, access to these tools? Because it's free, so I think we should push each other to have to provide more and more free tools, for citizen analysis, and also to train different people, especially communities. What happens when we have, just next generation of rangers that are community, that people that are living in the communities that are trained to use these type of devices. So we have the next generation of people that can mix in a very effective way traditional ecological knowledge together with modern science and AI, and when you merge these two together, you have very effective conservation strategies, circling back to data availability as well.
Josh, I want to bring up another point that was mentioned in some of the kind of opening responses, which is around using AI for renewable energy sources like solar and wind power. And I want to ask you kind of what role do you see for AI to help support that? This seems to be an area that there's kind of constant innovation and interest. I wanted you to see if you could kind of put that into perspective. AI is obviously not the silver bullet that's going to solve all this, but what role does AI have?
Yeah, happy to chime in. It looks like my video is frozen. I don't know if can you still hear me?
We can still hear you.
Okay.
You have a nice expression on your face, so you're good.
Okay, hopefully it resolves here. So in terms specifically of renewable energy and energy use overall, of course, AI can play a role in helping to optimize. AI is fantastic at grid optimization and helping us plan for grid upgrades and so forth. So that issue is definitely useful. AI can also help with modeling the potential for renewable energies in different geographies, helping us figure out how to most effectively deploy it, where to deploy it, and how to maximize the output from renewable energy. So that's really helpful. And then, on a related note, there are so many ways in which AI can help us with energy efficiency generally. And I think we may get into this later, but there are so many different opportunities for AI to be deployed specifically to reduce energy. Even the energy used in AI itself is going to be dramatically different in just a year than it is right now.
Great. And Raina, I wanted to ask as well, how are developing countries thinking about this question, both of using AI for renewable energy sources, but also kind of just broadly on that question of using AI to transition to a lower carbon future?
Sure. I mean, of course, there's a lot of interest, and specifically on the use of AI for energy in Mauritius, for example, in the process of creating a smart grid. The country has a smart grid policy, and that really helped for the country to make strides toward their renewable energy target as well. But that, when it's smart grid, it comes with all the automation for energy distribution. This, of course, has an AI backend to it. So I think that we are already starting to see these in these, smart grid projects or policy types of energy projects. And of course, there's a lot of interest in identifying good places for mini grids because, traditionally the grid planning was or the planning of energy was all grid centered, but now there's much more that can be done with the mini grids. And that really revolutionized the way that we approach energy access. And, as you know, there's more than 500 million people that we still need to electrify to bring in electricity to in sub-Saharan Africa. So that, I think it's a huge potential that a lot of countries are seeing. Again, in terms of generally on AI, again, there is appetite, but there's also a lot of uncertainty. And so as UNDP, how we've been approaching this is that the Chief Digital Office of UNDP has been trying to help on the of the country. Am I echoing? So the AI readiness would be things about, is it inclusive? Is there a data governance around the data management? We're trying to support at that kind of foundational level as right now. And I think, as this kind of readiness starts to evolve, more and more needs will start to come in. But there's a lot of appetite, that is for sure.
Thank you for that. It's really interesting to see the interest growing in this space. Constanza, I wanted to ask you first if you had anything to add to what Raina said, but also thinking about AI and how it might contribute to the development of smart cities and infrastructure, especially in Latin America, where I know there's been a lot of interest in moving towards smart cities and leveraging data and analytics to optimize infrastructure and services. What role do you see for AI there, and what kind of appetite do you see in that space?
For sure. Complementing what Raina said, in different applications, there's also a very nice nexus between energy efficiencies and agriculture, knowing that regions such as Latin America, like many others, are so strong, in agriculture practices. So one, all the conversation around AI for precision farming, and helping take decisions that are more energy efficient towards the same. That has to do as well, for example, the irrigation management, and knowing when and how to best irrigate, these huge croplands. And as well with, the resource allocation, when when AI is used for the yield prediction, you can also have better decision making on how to allocate resources. So on that end, and moving into cities, as of course, in Latin America, such as many other regions, the question of how AI can help us have more sustainable, greener, and more efficient, energy-wise cities becomes a must, nowadays. So we have not only, all the realm that has been happening for the last many years on the nexus of AI and transportation. For example, having, calculating the best routes that are more efficient, but also a conversation that is growing more and more in interest is the nexus between AI and the construction. So the built-in, the conversation about the carbon, of cement, for example, and, the high carbon footprints, the built-in buildings has, provokes this important question: how can AI help us to, one, democratize the biomaterials, two, to discover new biomaterials, and third, how can AI be leveraged to have a resource efficiency, and what material to use where. However, it's not like just let's sprinkle AI into cities. The conversation, of course, it's much deeper. It has to do more with regulation. It has to do more with incentives of the companies' adoptions and such. However, there's more and more promising areas to seeing how, one, nature-based solutions and are enabling better solutions in cities through AI, and second, how AI is helping us have better decision making at all levels.
Yeah, thank you for that. I wanted to ask, and I'll kind of open this up to anyone who wants to take it. There seems to be a little bit of a tension between, on the one hand, the critiques that I often see are, large agribusinesses, for example, are, responsible for large amounts of water use or pollution, right? And so they're seen as, they're portrayed as the problem. At the same time, generally, larger businesses are the ones that are going to be the ones who are able to make use of AI and make use of technology on a large scale. How do you see those two kind of components coming together? Are there opportunities to, make sure? I guess how do you see the tension maybe there in terms of what what these businesses can and should be doing, and how they can be seen as part of the solution, and not just kind of AI washing or greenwashing what they're doing?
Well, I'm happy to take a first shot at that. I think you've illustrated part of the tension well, which is that larger businesses are often in a better position to adopt advanced AI technologies. They have the capacity and the resources to hire in the limited talent that's out there that can really implement AI algorithms. It's very difficult for smaller scale businesses or nonprofits or governments to as easily access that talent, because the salaries are often quite substantial. There's also fundamental market efficiencies when you have a larger scale business that's able to aggregate data from a wide range of parts of the market. But that absolutely does live at tension with concerns about data privacy, concerns about how smaller scale businesses are interacting with those larger agribusinesses. So you see, for example, OEMs who are putting tractors, selling tractors, wanting to help support farmers in optimizing their operations, but they're doing that partly through a data collection mechanism. And when that is accompanied by appropriate data protections and full awareness and approval by the participants, that can be fine. But that needs to be done in the right context. So there's absolutely market value and opportunity at that large scale. But of course, it comes with the need for responsible implementation.
Thank you, Colin. That was a very articulate answer to my inarticulate questions. I appreciate that in particular. I actually want to stay on you for a minute, because I know you've done work around carbon dioxide removal technology, and that is in an area where I understand AI can help support the development there. I was curious, again, as we're talking about kind of the opportunities, can you expound on what that is and how AI can be helping in the development of that?
Sure. So carbon dioxide removal broadly is, of course, trying to remove CO2 that's already been emitted to the atmosphere, and it falls roughly into these sort of engineered approaches that are more technical in nature and nature-based, which are more related to forest growth and soil carbon. On the nature-based side, I had mentioned earlier the WRI and Meta effort putting out a global canopy height map. There are excellent ways that machine learning and AI is supporting forest monitoring and improving the ability to do carbon removal through forests in a valid way. We'd love to see advances on that in soil carbon, although it's much, much harder. And we've seen some unfortunate big fails on trying to use AI and machine learning in the soil carbon space. On the engineered side, a lot of those applications, the darling, the most obvious one is what's known as direct air capture. It's a version of removing CO2 from atmosphere chemically or through other methods. A lot of that relies on particular materials. I had mentioned earlier the advances in materials discovery accelerating rapidly computational materials discovery and innovation through machine learning and AI, that's absolutely helping and going to help more on direct air capture materials. And similar things may apply in some related areas. This isn't precisely in the CDR carbon removal space, but electrolytic hydrogen production and sustainable aviation fuel production often rely on advanced catalysts, membranes, and other materials. And there, I think the same logic about AI accelerating materials innovation will apply.
Thanks. Thank you, Colin. And Raina, I want to also ask you, about the challenges and opportunities of using AI for sustainable land use, particularly in developing countries.
Sure. Or maybe land use, and also in general, just to add on to what Colin was saying on the nature-based solutions, it's really important. And again, we kind of approach it in a policy way. So, for example, there is maybe an economic or financial incentive called the payment for ecosystem service. Mm-hmm. And I just wanted to kind of introduce that here because AI is still early in the process of automating all of this work. But what it is that when a farmer or local community conserves their environmental ecosystem, right? Like, so it could be water, it could be forest. A lot of it is actually happening in the forest sector, where, as you said, it's where the carbon is captured. Then they can get payments or compensations for conserving the forest. And this is a very innovative incentive and also a financial mechanism that brings the cash to the power of the farmer or to the farmers directly. But I think AI can play a lot of roles in this, starting from the WRI, deforestation. They also have a deforestation identification system. And also, all the much more very high resolution imageries that I understand also with the power of AI, it can also start to be much cheaper, right? Like instead of having all the very high resolution, we could also start to apply layers to it to make high resolution into very high resolution, for example. There's also about how do we verify that these things are happening on the ground. Ground proofing is very important, where what Constance was saying about for example, using sounds, for example, or there could be drones. How can we have this verification that reforestation happened or deforestation didn't happen? How can we automate that is another question that we're asking. So I think, going back to Daniel, your question, it's for us, we see that AI can be applied across this kind of, theory of change or a intervention that's already there, but it can actually really make it go to scale. If we can start to apply it across the value chain.
Can I respond to that? I think this is a super important area, and what I want to observe is that we see this a lot where there are AI and machine learning opportunities to lower the costs of monitoring to a specific level of certainty, and there really are opportunities there. Unfortunately, it's often very difficult for the organizations that are on the other side of this, purchasing carbon credits resulting from those that are monitored by those machine learning others. It's very hard for those organizations to really judge those novel AI ML methods. Are they valid? What's going on here? And many of them are valid and do really produce better, more accurate results for lower costs, but many of them aren't. And there's a real barrier that we've been seeing in terms of the capacity of the other end of the market to assess whether a novel ML AI algorithm is really performing, is really doing better, and that's a real stumbling block, which fundamentally relates, I think, to capacity to understand and evaluate AI ML methods.
It's a great point. I want to go to an audience question that we received before we kind of move on to some of the questions about the technology and the solutions. One of the questions that came in is, how can AI assist with the growing problem of climate migrants globally? So the challenges that climate migrants face in terms of the impact and where AI might be a solution. I want to open that up to anyone who wants to take it.
I'm happy to jump in. I mean, as with so many use cases in climate and AI, AI methods are likely to be pretty good at predicting where climate migrants are likely to go. Where will we likely see population movements driven by climate change? but prediction is not the same as solving the problem. So I think AI can play a role in better informing policymakers about where these problems are likely to occur, where we're likely to see major migration pressures, and what the driver, we know what many of the drivers are going to be, but that hands the problem off, or that can't just fall onto deaf ears of policymakers, who then aren't able to take action or develop solutions as a result. So this sort of predictive capacity is one piece of a solution, but it needs to be married with a commitment to policy, a commitment to ingesting that information at the policy level, and then taking policy action to respond.
Thanks, Colin. Reina or Costanza, anything else you want to add?
I can't sorry, go ahead.
No, sure, Reina.
I just wanted to say UNHCR, it's a sister agency to UNDP. They did have a prediction algorithm a few years ago, but I just wanted to check if it's still there. But they did have something like that. And I really agree with Colin that it's really, this is the start of a policy discussion or the analysis, or maybe it's not even a science-based, I guess. We need to start thinking of how we call this. But this AI generated scenario-based different foresight that can then inform policy decisions would be, I think, what I would say. We see a lot of this on the climate security discussions as well. Sorry, Constance, over to you.
Exactly. And I think, another perspective of, harnessing AI is also how can we educate ourselves more as a global community on the impacts of climate in migration, right? And how can we personalize messages, and how can we understand what different incentives, and motivators move people to the behavioral change aspect of learning, and how can we use AI to personalize this learning in topics as important as climate migration.
Yeah, thank you for that. I want to shift gears a little bit and talk a little bit more about the technology. I know we've been saying AI, and AI is the kind of umbrella term, but it's changing rapidly, right? Its capabilities are changing rapidly. How it's being deployed is changing rapidly, whether we're talking about in the cloud or on the edge devices. Josh, I want to come to you and ask you first. What are the emerging advancements in AI that you think have the potential to accelerate progress towards carbon neutrality? What should we be kind of looking for in the next year or so from NVIDIA and others in the field?
Yeah, it's a great question, and there's been a lot of ink spilled about the potential for AI to overwhelm the world with energy consumption and potentially emissions. But there are a lot of innovations that are happening in real time that are going to be counter pressures on that growth in terms of energy and emissions. So, for example, we at NVIDIA, we just launched last month our next generation of AI chip called Blackwell, and it's for training, for example, models. It's 25 times more efficient, looking at performance per watt, than the prior generation. So just in the time of 1 year, it's not 25%, 25 times more efficient, energy efficient than the previous chip and design that we had. So that huge increase in energy efficiency of the hardware and the software involved in deploying AI and training it is really, really profound, and it's hard to kind of overstate the potential impact of that over time. So that innovation is absolutely, I think, going to drive more access to AI and models and so forth, because it's going to become cheaper to run the same type of model. In 1 year, it may be 1/25th of the cost, or it may be at least cheaper and more accessible than it was in the past. Another way in which AI is evolving is in kind of model optimization. So in just similarly looking at relatively short timeframes, there have been significant increases in efficiency of models, especially through quantization and pruning technologies. I saw one example of the BERT model. Recently, there was an optimization of it called the StillBERT. It retained 97% of BERT's performance, but was 40% smaller and 60% faster. So both on the hardware side, the software side, there are going to continue to be lots of efficiency improvements. And you would expect that because we really still are at the beginning of this inflection point where AI is becoming broadly available. A lot of people are spending a lot of time trying to work on it, and there are huge incentives to get it right, to get it efficient, and to make progress here because there are huge advantages to companies and organizations that figure that out.
Yeah, Josh, I think it's really interesting because, we put out a paper earlier this year that looked at the, energy implications, energy use of AI models. And one of the papers I looked at that was, I based this report on, really tracked the energy efficiency of different models. What was interesting is that, of course, the kind of the cutting edge model typically was not that energy efficient, which you would expect because that wasn't the thing they were focused on. They were focused on how do you, maximize performance. But when you track the models over time, you saw, well, the ones that actually were deployed or, the models that, came after, well, then people started working on the efficiency part of it. I wanted to ask, you kind of alluded to this, maybe you could kind of maybe put a fine point on it since you have so many customers, how do they think about the market side of this in terms of, efficiency? Does that, because I think a lot of people look at, industry and they'll say, well, industry will just use the most energy. But it seems like costs are really a key factor here. Energy costs for deploying models, efficiency. Can you talk a little bit about how the market dynamics play out for, how customers decide whether to use a more efficient chip, whether they choose to use a more efficient data center or a more efficient model?
Yeah, sure. And I think you made a great point about there potentially being different approaches based on where you are in the life cycle of a particular model or AI use case. So at the bleeding edge, there's a lot of focus on performance. You want to get that amazing model trained well, whether it's Llama 3 or ChatGPT 4 or Gemini, what have you. If you do a really good job of getting that large model trained well, then it can be really effective, and it can be effective over a long period of time. And this is one of the issues that sometimes gets lost when we talk about the energy required for training, is that if you train up a model that has some staying power, that model could be used for a long time. And the inference associated with using the model actually has a much, much smaller footprint, or potentially does. And so those training costs get amortized over a long period of time, and it actually ends up being a lot more energy efficient than you would assume if you just look at the time required to train the model. But over time, as you suggested, Daniel, there are use cases where a smaller model might be just as effective or might be sufficient for your needs. One example I can think of is just within the past few weeks, we released a coding-related model called StarCoder 2. And we did this in conjunction with Hugging Face and ServiceNow. And we released 3 models. One of them was 15 billion parameters, one of them was 7 billion parameters, and one was 3. So you're able to select, which of these models do you really need? If you use the smaller model, it's more efficient. And for a lot of use cases, that may be sufficient. If you really need the best and the fastest and the most accurate, then you can use the higher parameter, larger model. So there's going to be a lot more optimization and efficiency as more and more models are deployed, and you can select the exact one that meets your needs.
Great. And so, I really want to spend the rest of our time together here talking about, how do we move forward in this space and what policies can support that. And Colin, I wanted to start with you again. There was that great ISEF report that, really kind of laid out this agenda and roadmap for where we go. What policies do you think should be prioritized, especially, given the fact that it's hard for legislators sometimes to get things done. So we need to kind of focus on, the few big ideas are the ones that I think maybe have the most promise. What's your message in terms of what should be done in terms of, getting AI solutions for carbon neutrality at scale?
Yeah, so I think my one-word solution is people. I think the real gap here that I see is multiple challenges around capacity. So to start with, we have some wonderfully smart AI, machine learning folks who can run a model, make it stand on its head and dance, and that's fantastic. And they, in their minds, these AI machine learning solutions have actually been around for a very long time. I mean, as a computer vision person, we've had AI computer vision for over a decade. Ho-hum, it's a standard tool. Why is everyone suddenly so excited this year? Large language models. But on the other hand, we have folks who are very deep about climate solution needs, what would really advance the state of the art in reducing emissions in various sectors, in heavy industry, in the power grid, in ag. Those two communities really don't have that much overlap. As you look for people who can really speak both languages or who can communicate across those two silos of expertise, we still are very, very limited on the number of people who can cross across. So my first sort of area of focus, I think, is trying to build that crossover more. We've seen R&D grants from philanthropy and some from government that are trying to intentionally create research teams that bring folks from both sides of that fence together. I think we need a lot more of that. We need to train a lot more. Then shifting, I think, to some of the conversation we've had about more developing world, I think there's a real challenge to getting these skill sets more globally distributed. And I would love to see, particularly maybe philanthropic funding, to bring talent from all over the world to training opportunities, teach people modern uses of machine learning, modern tool sets, and then give them the ability of access to those assets, but work back in their communities. So I think that's we need to keep focused on that aspect of the people problem or people solution set we need to look at.
Yeah, and staying on that point, maybe Raina, I can go to you, and then Constanza. First, what's, for example, UNDP doing to kind of support that capacity building around people? And Constanza, also just want you to weigh in on this question. I mean, one of the reasons I think this question is so interesting around AI for carbon neutrality is, I mean, of course, it's usually the developing countries that are leading in technology development, but we know when it comes to climate change, it has to be global solutions. And so trying to figure out how do we, make sure that solutions that we're developing aren't just for the wealthy countries. Very curious your thoughts in terms of how we really scale these out.
Sure. We do have capacity building, but I think for now we are trying to lean on more partnership opportunities. Again, there's a lot of solutions out there, like in the developed countries, that developing countries can use, but not to import them, right? We always want to make sure there's a local digital ecosystem that evolves after any kind of training comes. So we do try to put in some thoughts to make sure that it leads to local capacity building. And then on the AI readiness as well, I think what we're trying to do is to think through how can AI be more transparent. And this is a question, again, it's very difficult, but we see that, and going back to the data, lack of data question, the voice of the women might not be as prominent in this test data. We all know, there's some examples of discrimination happening because of that in the HR field, for example. So how do we make sure that the voices of the indigenous communities, for example, people who don't speak the mainstream language, and, if you look at sub-Saharan Africa, language, the top 5 African language, not English and French language, is not really represented in the AI models as of now. So, how do we make these are inclusive? How do we make it transparent so that, as Colin was saying before, I've seen several countries resist using a ready-made solution, even if it's a very good AI solution, because it was a black box and you don't know what data, you don't know what the methodology is. Perhaps that kind of transparency is where we've been trying to do through use cases, but also something that can be a bigger policy discussion.
Constanza, anything to add on that?
Sure. I would say 3 things. One is that I think we have to also widen our focus and our priorities, like going from carbon neutrality to nature positive, because I feel sometimes we're too focused on carbon when actually also the impact in biodiversity is as important and should be coupled with these conversations, right? So widening our priorities as a global community on this. Second, and echoing Reina, the climate justice lens and the regenerative lens, on these conversation is very important, because one thing is a technology layer, but what is at the center of these, or what should be at the center of these deployments and these developments, is a community. So does the community understand, what's being developed, or is it just, are we using these fancy words to describe solutions where they don't have necessarily a stake in its development? And I could go on and on, but I would conclude that point with the shared benefits. Is a community and the local community having a shared benefit of whatever is it being developed, or is it just, they're part of a beneficiaries, and they're ticking a box, and the community is ticking a box, rather than being a shareholder, and a stakeholder, in decision making. And third, there is an imperative need to de-risk, in my opinion, innovation for nature-based solutions, another type of solutions for this realm. And AI has a very promising role in de-risking finance for this. So also not only embedding transparency, but also using AI to create more transparency, and more data-oriented actions can also lead to shorten the finance gap needed for this both carbon and biodiversity conversations.
Thank you. And Josh, kind of a similar question, how should, I guess, policymakers ensure that, AI-driven and climate solutions are benefiting both higher income and lower income countries, as, countries like the United States, Canada, the EU, UK make these big investments in AI? What should they be thinking about?
So I'm actually really optimistic on this front about the kind of inevitable positive impacts across the globe of AI. So I think AI is actually going to have a more positive democratizing development impact than any other technology I can think of, because technology that's developed, for example, in one highly developed country can often be deployed, maybe not as effectively, but at very low cost in another location. So I think the potential benefits of AI, it's really, in my view, inevitable that significant benefits are going to accrue to the developing world as AI becomes cheaper, more accessible, and investments that are made even in more developed countries are realized. The benefits are also realized in the developing world. And there are a lot of potential ways for this to happen through education and healthcare. And of course, agree with Reina and Constanza, of course, about the need for focusing on local needs, local populations, and trying to make it the AI models and use cases as locally tailored as possible. And that's another area where I think we can all agree in that type of investment and goal. But ultimately, there's so many opportunities here to help the developing world in particular, and to potentially close the gap because it's a digital technology. It's a technology that's more easily imported and exported than other revolutions have been based on.
So one of the parts about AI that I think is really interesting here is that we're seeing the development of many open models, right? And these open models allow for anyone to take the model and fine tune it and adjust it for local needs. So unlike some technologies where you might say, oh, it's just it's this kind of technology developed in one place and we're trying to deploy it somewhere else. Because of the nature of the technology, because it is open, it allows for local development, local use cases. But to do that effectively, in many cases, you do need data. You do need local data that can be applied to it. Colin, I wanted to ask you about this because one of the recommendations that I know and that you've talked about before is around data, and that we need the right data for AI-enabled climate solutions. So what data exactly should we be prioritizing, and who should be the ones making it available?
Well, so of course we need the right data, and Reina and others have pointed that out. It varies enormously by the use case. I do think there's a shockingly large amount of remote sensing data that is increasingly available, particularly useful in nature-based biodiversity issues. If it's approached right and used well, it can be very powerful. I've frequently found that there are far more satellite sensors available from far more national space agencies than I had any idea existed, and too much of that community is stuck within just using Sentinel-2 or just using Planet. So there's for some use cases that's part of the answer, big part of the answer. I think there are citizen science ways to leverage cell phone and other data in clever ways. That's not a panacea, but that can be very valuable. But it really does depend on what climate solution area you're talking about, and the responsibility for collecting that lies in a lot of different places. I will say a message I would convey to many stakeholders in this, particularly private sector actors who sit on a lot of data they might not have thought is relevant to climate. It might be relevant to climate because there are innovative ways to use that. And it might also be very valuable for you to find ways to release it in anonymized ways. Hopefully everyone's heard of the Netflix challenge, the story of that early AI effort where movie recommendation data were released by Netflix with a challenge to the world for people to develop better algorithms for movie recommendation. And that's only one anecdote, but it did lead to usable, valuable advances in algorithms based on the public release of anonymized large data sets. That's a scenario I would love to see more companies embrace, because there are smart AI people out there who can probably do a lot more with your data than you can internally. So you should be working with those external AI experts by releasing data in appropriate ways.
Great. And I want to give Josh, Constanza, and Reina an opportunity for a last word. And maybe I'll frame the question this way, but if you want to go in a different direction, you're welcome. I'm really curious about basically where there are opportunities for government to collaborate with industry stakeholders to ensure both AI is being deployed effectively and responsibly in support of sustainability, and really what that collaboration and coordination should look like. And just as kind of one example of maybe a challenge I see, when I've looked at 3D elevation data in the past, even within just the EU, every country was kind of doing it their own way, and there wasn't a lot of consistency. And so opportunities to use that data effectively for modeling are somewhat limited because of the fact that again, everyone is just doing things differently, and again, areas where people all generally are have the same goals, but they're not well coordinated. Globally, scaling that up across all these different types of data sets, that's even a bigger problem. So how do we start thinking about basically where that collaboration should look like, who should be kind of leading on it, and your thoughts on that? And why don't we go, Josh, Reina, Constanza, I'll give you the last word.
Sure. Yeah, it's a great question. Absolutely, government and private and academic collaborations here are really, really critical for us to get AI right. And there have been some successful examples of this. And one example that I think is notable, the DOE recently issued an RFI asking for input from the private sector on how to deploy AI in sustainable ways at the federal government. And so that gives organizations outside of the government an opportunity to advise, to suggest, to recommend, and then the government can potentially become an example of how to deploy AI sustainably and for sustainable goals that can be a model later on. And I think one really critical thing in this kind of public-private collaboration that we need to get right is effective regulation. It's really tempting to want to jump out in front of this very huge growing technology and want to make sure that it's safe, make sure that it's being deployed responsibly and so forth. But if it's not done well, if the regulations are poorly tailored, then they can end up having perverse and detrimental impacts on the deployment of AI. For example, if energy efficiency regulations focus on anachronistic metrics like power usage effectiveness, this is something that's being kicked around in the EU, it could potentially cripple deployment of AI and prevent us from capturing all these many, many benefits that we all want to see. And at the end of the day, I think, so transparency, certainly there's a role for government to expect transparency, to require transparency so that we can have the data and make thoughtful decisions about AI deployment. But it's really critical that we create an environment where AI can be deployed and the huge benefits of it can be achieved locally as well as throughout the world.
Thanks, Josh. Reina.
Sure, I'll be quick. I know we're out of time, but I think there's many use cases that the government wants to solve, and I think it's really about picking some of these use cases, working together, building a solution, and always applying this approach of open source, open data, which was already discussed today, as well as capacity building. I think it really, in the end, it boils down to how much capacity can be built in the local community within the country. So if there's partnerships that can be built in that way, I think that's a huge win for this climate and nature areas.
Thank you. Constanza?
I would add the importance of multi-stakeholder approaches. So for example, in our work in Mexico, in Yucatan, we work together with the government of Yucatan that has been, and part of this is from the design phase of this project. And that creates feedback loops from lessons learned into policy that are in kind of real time. So just as an example from our work, the government had the data and the results of the first phase of our work to be able to create their 30 by 30 policy that they just launched 2 months ago. And it was a result of the lessons learned on site together with this working group.
Well, I want to thank everyone who participated and watched and submitted questions. I want to thank our excellent panelists for this discussion today. I certainly learned a lot, certainly lots of opportunities that are emerging and that we'll see in the years ahead. So really look forward to tracking your work, and I appreciate you taking your time out of your busy schedules to share some of your thoughts with us today. Thank you.
Thanks.
Thank you.
Thank you.